So we know different methods to find the root of an equation like bisection method, false position method and Newton-Raphson method. Now we are going to look at the secant method to find the root of an equation. You will see that this method is just like the false position method, which is also called regular falsy method, but it is simpler than false position method. So we have an equation f of x equal to 0 and we have to find its root, meaning that we have to find some number b, let's say, that when you plug it in the function it gives you 0. So finding this number b is the goal. Now we know that f of x is continuous on some interval ab, which we are calling x0 x1. We are just denoting ab as x0 x1 such that f of x naught, let's say, is less than 0 and f of x1, let's say it is greater than 0. So based on this information, let's sketch the graph. We have x-axis, we have y-axis, somewhere here we have x0, somewhere here we have x1, and we also know that f of x0 is less than 0, so it is somewhere here below x-axis roughly, and f of x1 is positive, so somewhere here roughly. Now this point has the coordinates x0, f of x0, and this point has the coordinates x1, f of x1. We know that the function f of x is continuous on this interval x0, x1. So there has to be a continuous smooth graph in between x0 and x1. So we have this graph, and wherever this graph cuts x-axis, that is the root. So we have to approach towards this root by using the secant method. So what is a secant line? Let's say we have a curve, and any line that cuts the curve at 2 points, this line is called a secant line. So back to our picture. We have a graph. This graph is cutting x-axis at some point, and that point is the root. It is this point. This is the root, and by using the secant lines, we have to approach towards this root. So the points x0, f of x0, x1, f of x1, these 2 points are on the graph. So we will join these 2 points by a secant line, straight line, like this. This line has cut x-axis at a point, and we are denoting this point as x2, and at x2 y coordinate is 0, so this is this point. Now let's take this straight line, secant line, out of the frame, which is this one. On one end of this line, we have the point x1, f of x1. On another end, we have the point x0, f of x0. And also there is a third point which is lying on this secant line, which is x2, 0. We are going to write an equation of straight line. This is a secant line but also the straight line, so we have to write an equation of this line. We have 3 points which we can use to write an equation of the line, but to be able to write an equation of a line, you just need a point and the slope of that line. For example, let's say there is this line which is passing through the point AB and it has the slope m. Then the equation of straight line will be y minus the y coordinate of the point through which the line is passing. Here it is b, y minus b equal to slope of the line x minus x coordinate of the point through which the line is passing. So this is how you write an equation of a straight line. Back to this line for which we have to write an equation. This line is passing through 3 points. Let's pick the points x0, f of x0 through which the line is passing. So we will use this point as AB in the previous example, and we need the slope. By using these 2 points, we can write down the slope. So slope formula is difference between y coordinates f of x1 minus f of x0 divided by x1 minus x0. So now we are going to use this point x0, f of x0 and this slope to write an equation of the straight line. Y minus y coordinate of the point through which the line is passing is equal to slope, which is this one, f of x1 minus f of x0 over x1 minus x0, x minus x coordinate of the point through which the line is passing, which is x0. So we have an equation of this secant line. Now let's look at this secant line again. It was passing through the points x0, f of x0 and x1, f of x1. But there is another point, this one, x2, 0, which is also lying on this line. So we already have an equation of this secant line here. But now the point x2, 0 is also lying on this line. Let's make this point lie on the line. But before that, let's say you have an equation of straight line y equal to 2x plus 3 and you say that the point 0, 3 lies on this line. How do you make this point lie on this line? So 0 goes in the place of x, 3 goes in the place of y. Everything else in the straight line remains same. So y is 3, 2. In the place of x you have 0 plus 3. Both sides are same. Let's now make this point x2, 0 lie on this line. So x2 goes in the place of x and 0 goes in the place of y. Everything else remains unchanged in this equation. So y is 0 minus f of x0, f of x1 minus f of x0 over x1 minus x0. In the place of x we have x2 minus x0. So x is replaced with x2 and y is replaced with 0. Everything else remains same. And now what we are going to do is we have to find x2 from here. So why do we have to find the point x2? So we started with the interval x0, x1. And when we joined f of x0 with f of x1 by a straight line, we got a point x2. So this is the next point that we will find. x2 is not the root, but it is closer to this root. So we find x2. So by using the cross multiplication, we have minus f of x0 into x1 minus x0 divided by f of x1 minus f of x0 equal to x2 minus x0. Since we have to find x2, so we'll keep x2 on one side and x0 will be on another side. With the change of the sign gives you this. So this is how we find x2. Now let's look at the picture again. After finding x2, the root lies in the interval x2, x1. So we will join f of x2 with f of x1. Again, we started with the interval x0, x1. And then we joined f of x0 with f of x1 by a straight line. We got a point x2 because the straight line that we got by joining f of x0 with f of x1 was cutting x-axis at point x2. Now the root is lying in the interval x2, x1. So we will join f of x2 with f of x1 by a straight line. So f of x2 is this and f of x1 is this. Let's join f of x2 with f of x1 by a straight line, and this straight line has cut x-axis at another x. We are going to call it x3. We can see that now the root lies in the interval x3, x1. So let's join f of x3 with f of x1. Let's look at x3. We have to find first f of x3, which is this. Join it with f of x1 by a straight line. Now it has cut x-axis at point x4. We can see that now the root lies in between x4 and x1. So we will join f of x4 with f of x1, and when we do that, we join f of x4 with f of x1 by a straight line. So this actually passes through the root. This straight line passes through the root, so we will call it x5, and that is the root. So the point is, we keep on finding iteratively x's. Like we started with x0, x1, then we found x2. Looking at the formula for x2, we can write x3 equal to, first of all, look at this, x2 equal to x0 means the difference between this should be 2 minus 0. So when we are writing x3, we have to put the number here such that difference between this and this number should be 2. So it would be 1. Just like here again, x2 equal to x0 minus f of x0 into x1, which is the number after this, minus x0 divided by f of x1 minus f of x0. So back to writing x3, here x0, f of x0, x1 here, then here it should be f of x1. Just we are copying the pattern for x2. So into, after x0 you have x1. So if we already have here x1, so here we will have x2 minus x1 divided by, when we had x1, x0, here we had f of x1 minus f of x0. Now we have x2 minus x1 here. So we will write here in denominator f of x2 minus f of x1. The same way, let's write x4. It should be x2 because the difference between these two should be 2. Minus f of x2, x3 minus x2 whole divided by f of x3 minus f of x2. Now we are ready to write a general formula, which is x n plus 1. Here it should be x n minus 1. Just like this, the difference between 4 minus 2 should be 2. 3 minus 1 should be 2. The same way, we have put n minus 1 here because n plus 1 minus n minus 1 should also be 2, and let's check that. The difference is 2. So back to this, xn plus 1 is equal to xn minus 1 minus f of xn minus 1. The number after x minus 1 is xn minus xn minus 1 whole divided by f of xn minus for this minus for this f of xn minus 1. So that is how we write this formula, and this formula is to find successive x's by using secant method. And one of these x's is going to be the root. And how would you know that? You have to stop and you have found the root. So when you plug x7 in the function, and if you are looking for the root correct to two decimal places, and you have on the right of the decimal 2 zeros and third is some digit, then you will say that yes, x7 is the root correct to two decimal places. So now we have derived the formula for secant method. In the next video, we are going to attempt a question by using the secant method to find the root of an equation.